This video is going to be a geometric proof of the compound angle identity cosine alpha plus beta is equal to cosine alpha times cosine beta minus sine alpha times sine beta. And to prove this compound angle identity geometrically, I'm going to be using this diagram over here. And let me first explain this diagram here to you so that I can move on to the proof itself. The angle here is alpha and the angle is here beta, and these two triangles have been put on top of each other so that this angle here is going to be equal to alpha plus beta, and we can create, with this line segment here, we can create another triangle here to find its cosine. So this line segment here, which is OB, is perpendicular to CB, as it has been noted here, and this line segment CE is perpendicular to OA, and of course, let me just note that it should be like this, and yeah, that's it. And to prove this identity, first we need to get the angles correctly. So to get the angles correctly, we need to use one rule, one geometric rule, which I'm sure almost everyone who's watching this video already knows. It is going to be a transversal, which crosses two parallel lines, creates the same angle in these parts. So if this angle is equal to alpha, and if these two lines are parallel to each other, then the angle here, the small angle here, should also be alpha. So let's just note that. And we can already see that this angle here is 90 degrees and this angle here is alpha. So this angle, the small angle, acute angle here is going to be equal to 90 minus alpha degrees. If this angle here is 90 minus alpha degrees and this angle here is 90 degrees, then this angle, which can be named as BCR or RCB or ECB, whatever you want, is also going to be equal to alpha. This is important for us. Now we know that this angle here is equal to alpha, is alpha degrees. Then we can move on to our calculations. So cosine alpha plus beta, what is cosine alpha plus beta in this diagram? So cosine is the adjacent side over the hypotenuse. So the adjacent side in this triangle, which forms the angle alpha plus beta, is going to be OE. So OE over OC. And because OC is equal to 1, this is just going to be equal to OE. So this is equal to cosine of alpha plus beta. So OE is going to be equal to cosine alpha plus beta. And the next question is, what is OE equal to? So OE is equal to, as you can see, OE, which is this line here, OE is equal to OA minus RB here. So OA minus RB. So now we know the components of OE to get the value, to get the answer for cosine alpha plus b. We can move on. So we take these parts separately. So let's first start with, let's say, RB. RB. What is RB equal to? RB is equal to CB times sine alpha. So RB is equal to CB times sine alpha. But what is CB is equal to? So just because CB is in front of the angle beta here, it's going to be equal to OC times sine beta. But because OC is 1, it's just going to be equal to sine beta. So this is equal to sine beta times sine alpha. Now we have an expression for RB. Let's move on to OA. OA, which is the side here, is going to be equal to OB times cosine alpha. Then what is OB is equal? What is OB equal to? OB is the adjacent side to this angle beta here. So it's going to be equal to OC times cosine beta, but because OC is equal to 1, it's just going to be equal to cosine beta. So OB is going to be equal to cosine beta times cosine alpha. Now we can finally, we have the components, so we can get to OE. OE is going to be equal to OA, which is cosine alpha times cosine beta, cosine alpha times cosine beta, minus RB, which is equal to sine alpha sine beta.